Hello. So, guys, we're going to do functions, right? So, what I'll do, I don't know, but I'm thinking I'm going to divide this video into certain parts, right? So, to make it easier for you to understand. The main four functions that we're going to do, we're going to look at the linear function, which is your straight lines. We're going to look at the parabola, we're going to look at the exponential and hyperbola. These are the four functions that we're going to look at, and then we add trigonometric functions, right? But we like to cover trigonometric functions when we do trigonometry. So this is what you'll be doing until grade 12. So these are the basics. Once you grasp it here in grade 10, you are set for life, right? So the first thing that we have to understand before we can even go to talking about functions is to first explain what a function is, right? So a function, in simplest terms, is a mathematical relationship between two variables where every input variable has an output variable, right? So what we are simply saying is that in simplest terms, we compare two things, right? We have y and then we have x, right? So we want to check the relationship between y and x. So that is what we mean when we say it's a mathematical relationship between two variables. So we want to find out whether they're directly proportional, like when x increases, y also increases at the same rate, right? Giving us a straight line. Or it might happen that you have a relationship that is going like that, right? Or it might happen that you have a relationship which results in something like this, right? All these represent functions. All these represent functions. So no matter what type of a graph we get, it shows the relationship between two variables. That is what I want you to understand. That is functions in simplest terms, right? So the first thing that I want us to look at, it's the different notations that we are given when it comes to functions. They use different notations. We can represent functions in different notations, right? The first notation that we can use is called the set notation. Right? It's the set notation. So what happens in the set notation? We take this first with a set, we represent things as a set, right? So we have what we call domain, and we have what we call range, right? So I want to explain this before we can, we are going to do a lot of domain and range for each and every function that we're going to do. Remember, I said we have four main functions, right? I said we have linear functions. Let me write them aside. We have linear functions. We have quadratic, which sometimes they are often called parabola or parabolic functions. And then from there we have exponential, and we have hyperbolic or hyperbola. These are the four main functions. Remember, I said we also have trigonometric functions, but we mainly do those ones when we do trigonometry, right? So for each of these functions, they can represent them differently, right? In different notations, right? So set notation is one way in which they can represent these functions, right? Set notation. So I'm saying that in set notation, we look at domain and range. So the question is, what is domain and what is range? Remember that I said we only compare how many variables? Two variables. So meaning that domain is a set of x values, always set of all x values. This is a set of all x values, whereas your range is a set of all y values. This is a set of all y values. So then what is it that, the way that you can remember this without creaming, this is how I used to remember this. You see this G is shaped like a Y. When you write G, you write this. So you remember that this is for Y values. If range is for Y, obviously domain will be for X values. This will never change because it will always be like this until you get 2 and 3. Domain, when they say domain, they want set of all X values, and when they say range, they want all set of Y values. So meaning that in a set, we have different brackets in it, right? We have brackets that are like this. We use this bracket for sets, right? When you see this bracket, you see a set, it represents a set, right? Set simply means package, right? Everything. When we say set of all X values, we don't want to know that X is 1, X is 2, X is 3. We just say X values, or we just say X, we just say X is an element of real numbers, right? That is a set. When we say X is an element of real numbers, that is a set. We mean that every number will be an X value, right? Or we can say X is an element of integers. You know what integers are. Or we can say X is an element of whole numbers, X is an element of natural numbers. It means that if we say X is an element of whole numbers, it means that every number from 0 up until Jesus comes, that number will be what? Will be part of that specific set, right? You are going to understand it. It will make sense as we go along. So with that being said, another type of bracket that you have to know is a solid bracket, the one that is like this. This one represents what? It tells you that that specific number is included. It's included. Don't worry if you don't understand now. It's going to make sense as we go along and deal with functions. And then the last we have is the curved, the normal brackets that we use to. These ones, they tell you that it's not included, right? It's not included. Not included. So if I could give you an example of how they use, you're going to see this more specifically when we do these types of functions, the quadratic ones, right? So let's assume that they give you something like 2 is 2. And another thing, you know that your coordinates, your pen, it's always x is to y, always x is to y, not the other way around. It's always like this. So when they give you something like this, let's say we say 2 is to, let's say 10, right? And then for this one, they use these brackets, these two brackets, they can be used in one pair. But once you use this one, you can combine it with these two, right? The moment you use this set, I don't know, the moment you use this one, you use it alone, right? The moment you use this one, the opening bracket and the closing have to be the same. But with this one, you can start with the solid and end with this one because they have different meanings. Another way they represent these ones for a curved bracket, when you're doing inequalities, for your curved bracket, they use open dot. It's open dot. For this one, for solid, they use solid dot, meaning it's included, right? You would see something like this when you, I'm sure you did your inequalities already, but if you didn't, you tell me. There's something like this when you do inequalities, right? So what does this mean? How do you read these graphs? It means that, let's say this was, they told you that this, they just wrote something like this. And then for this E, guys, don't write it like this and don't write it like this. You'll be wrong, right? It's like this. It's like a C, and then we put that in between, right? So this is how do you read this? X is an element of 2, right? X is an element of 2 to 2 to 10, right? But this 2 is not included, right? So meaning that X is greater than 2, right? X is greater than 2. How do we know it's greater than 2? Because we're starting at 2, we end at 10. So from 2 to 10, we are increasing. So X should be greater than this one, but it should be less than 10, right? But it's less than 10. But something tells us that this 10 is included. How do we know? Because of the square bracket. I told you that the square bracket means it is included. So when it is included, we then introduce that line, right? So it means X is greater than 2, but less than or equal to 10. This equal to means it's included, right? If it was written like, if this was also a solid bracket, we would put that equal to sign also here, right? But if it doesn't make sense, don't worry, guys. It will make sense as we go along. So that is, when we say set notation, it means we will simply use these brackets, right? And always when we say set notation, you will see element of real numbers, element of natural numbers, or element of this is your set notation, meaning that they'll give you, you'll have something like this. X, right? They tell you maybe X is an element of real numbers. Then they tell you, but X is greater than 0. And then again, they put those brackets. So how do you read this? This is telling you that X is an element of real numbers. So any number that is real, right, it is part of X in this case. But we only consider the ones that are greater than 0. Although even the negative numbers are real, we only want the ones that are greater than 0. So that is a set, specific set they are giving us, right? Another example, they can maybe say that y, and then, sorry, Jesus. And then they write y is an element of real numbers, right? Let me not use real numbers this time. Let me say y is an element of natural numbers, right? And then they tell you, we know that natural numbers are all numbers from 1 until, right? Not including 0. But whole numbers are numbers from 0 until, right? So they say y is an element of natural numbers. So since we know that natural numbers start from 1 going all the way, right, to infinity, then we have to be specific, right? Which natural numbers? Then they can write something like this to say that y is greater than 3, but less than or equal to 5. So how do you read this? They tell you that y is an element of natural numbers. Yes, we know what natural numbers are, but they cut us, right? They are specific that within those natural numbers, we only want 3 to 5, but that 3 is not included, right? Remember I said when they use this, whether they use this sign or they use this one, right? It simply means that it's not included. You use these brackets, curved brackets. The moment they use this one, the less than or equal to, we don't care whether it's looking that way or it's looking that way, but what we'll use is solid brackets, right? And if they want you to use dots when you're doing inequalities, this is where you remember that this one is for curved brackets, and when you shade it, it's for solid. That's just how the different ways in which they express these things, right? So I hope that makes sense, guys. I hope you understood that. So set notation is the first way in which we can express our functions, right? It's the first way in which we can express our functions. And then the second way in which we can express our functions is by using interval notation, right? It's by using, let me write it down for you. It's by using interval notation. So how do we use interval notation? So your interval notation can be used to represent an interval of real numbers, right? So here it's where we strictly deal with these brackets. Either we use these brackets or these ones, but we are no longer using what? A set. Meaning in set notation, you will never find these two brackets. You only find these brackets for set, right? Those ones that represent a set. Now, when it comes to interval notation, there's no need for us to write x as an element of what, or y is an element of what, right? So the moment you see these brackets and the moment you see x is an element of something, we don't care whether it's real numbers, natural numbers, or integers. And the moment you see either y is an element of something, then you know that that is a set. So for you to notice or to see a set notation, look at these brackets and you look at whether x is an element of something or y is an element of something. That will tell you that is a set notation. When they say write something in set notation, just remember you have to use these brackets and say whether at that time you'll be dealing with x values or y values, you use that to say it's an element of either real numbers, natural numbers, or integers, depending on what you're given, right? So when we go to interval notation, we only see these brackets, curved brackets, or we see solid brackets, right? So you might be given something like this, right? So this simply means these curved brackets are sometimes called round brackets, right? They indicate that the number is not included, right? As I said, the number is not included. So this interval includes all real numbers greater than but not equal to 3 and less than but not equal to 11. So meaning that x is greater than 3, but that 3 is not included because it's not a solid bracket. And then x is less than 11. So meaning it's 3 to 11. We count from 3 to 11, but we don't include 3 and we don't include 11. We can also use it. This one you'll see it when we do parable, right? They can also use a round bracket and say negative infinity. This 8 that is just horizontal, 8 like symbol, this is for infinity, right? They say negative infinity to negative 2, right? And then they also don't include these two. They are both curved, right? So these round brackets, again, are always used for positive and negative infinity, right? For negative infinity, we mean any number that is negative. We don't care until because numbers don't end, right? So what we are saying is that this interval includes all real numbers less than but not equal to negative 2, right? You know that negative 3 is less than negative 2. Negative 4 is less than negative 2. All the numbers, negative 3, negative 4, negative 5, negative 6, until, they're all less than negative 2. Negative 1 is greater than negative 2. So what this is simply saying is that any number, right, if I was to represent this in a timeline, I would say this is 0. You know that on your right hand side you have your positives, right? So you would have your 1, your 2 until, and then this side you have your -1, your -2, your -3, and so forth. You continue going that way. So this notation is simply saying that from -3 all the way to all the -4, -5, -100, all the negatives that will come, right? It says that x is between all the negatives that side until 2, but that 2 is not included. So we end somewhere here. So what we are basically saying is that x is less than -2, right? X is less than -2, right? X is less than -2. This is the notation because we can't use negative infinity. I hope that makes sense, guys. So the last example I can give you so that you understand this one is if maybe you're given something of this nature. This this means that this 1 is included, right? We start here at 1. We start here, it's included. Then we go all the way to 9, but that 9 is not included, right? That 9 is not included. Meaning, if you were to represent this in terms of the simple inequalities, right, that we are used to, you would say that x is greater than 1 but less than 9, right? But it's included, so you put that equal sign. It's as if you always put x in the middle, then from there you read whether it's less than or equal to, then you put these signs, right? Because guys, if you don't understand these things, then I won't be able to continue because I'll be wasting my time. So another notation is function notation. Another notation that I want you to know is function notation, right? Let me erase everything. The last notation that I want you to know is function notation, which is the one that we'll be dealing with all throughout all the functions that we'll be doing. We'll be doing function notation. So in your function notation, they tell you that, remember we said that we use 2 variables, right? You have an input, go to process, and then finally you get your output. This is how functions are. So you will have something like, let's assume you have y is equal to 2x. Sometimes for process they use rule. It's the same thing. Rule of process. You have 2x plus 1. Right? This y can be represented in many ways. The one that they like is f of x. When you see f of x, it simply means y. They can use any letter. They can say a of x, they can say h of x, they can say z of x, anything of x. That simply means y. It's y. It represents the y value. So what this is simply saying is that if you were giving the x values this side, right? and you're given a rule. What is the rule? It's this one, the whole of this, to say we have x values, we have the rule, and then you have y values, right? So this equation, the equation that you're given here, this expression, it simply means that for you to get the y value, you substitute the x value here, and then you multiply it by 2, you add it by 1, you get the x value, right? So this is the rule. The rule is 2x plus 1. This is your rule, right? Let's assume our x value is 2, another one is 4, and then let's take a negative 1 and say negative 5, right? So what we are simply doing here, we want to find out what is the output when the input is 2. What is the output when the input is 4, right? What is the output when the input is negative 5? That is what we are trying to find out, right? That is what we are trying to find out. So if we substitute 2 here, where there is x, we put 2, right? 2 multiplied by 2 plus 1. What is 2 multiplied by 2? It's 4. 4 plus 1 is 5. So meaning for this rule, if the input is 2, the output is 5, right? So meaning we have something like 2 is to 5. Because remember, they are represented x is to y. This is a coordinate on its own. When the input is 4, 2 multiplied by 4 is 8. 8 plus 1 is 9, right? So meaning that our coordinate will be 4 is to 9, right? Here you only use these brackets. They didn't say anything about including or excluding, right? We are just using a pair, right? Negative 5, what is the output? What is 2 multiplied by negative 5? It's negative 10. Negative 10 plus 1 is negative 9, right? I hope you understand. So these are the two variables. So everything here, it all comes back to what I said when I started, that functions is just a mathematical relationship between two functions, right? So they can say find the value. Let's assume that they represented y in terms of f at x. When they say find the value of y when x is 2, like here, what you'll do, you write f instead of it was x inside this bracket. Instead of writing f of x, because now they're specific that they want the value of 2, you put 2. So meaning f of 2 is equal to, you come to the rule that you're given. F of 2 is equal to 2, where there is x, you put 2, like that. Then plus 1. Simple, right? If they say find f of 2 plus 4. Yeah. Now I want to see if you understand. So what they are simply saying is, where there is x, right? F of 2 is like this. This is f of 2. But they are saying in this add 4, meaning you first do f of 2. This is f of 2. And we got that the answer will be 2 by 2 is 4 plus 1 is 5. So what they are simply saying is take that 5 and add it with 4. This is what this is basically saying. F at 2, where there is x, you substitute 2, right? Like here, substitute 2 plus 1. But the whole thing, on top of the whole thing, you add 4, right? So that is it. But it's not always the case that we'll be going from the input to the output, right? We got negative 9. Then they can say, let's assume that they tell you that here maybe it's 15, right? So you already have the output value. What they want from you is what? Is the input value. So how will you then do this? You reverse the whole process. You reverse the whole thing. So it means that in this rule, you substitute, where you see y, you substitute 15, because this is y values, right? So it will be 15, it's equal to, we are looking for x, right? So we have 2x plus 1. We don't change anything, we only substitute what we're given, right? Here we were looking for y. That is why it was like this. We don't change what you want, you only change what you're given, you substitute. So for this one, what we'll do, obviously you solve for x, this goes to that side, it will be negative. It will be 15 minus 1, which will give you 14, which is equal to 2x. Then from here, what do? You divide by 2 on both sides, divide by 2, divide by 2, and then you find that your x is 7. So meaning for you to have a product or output of 15, your input must be 7 for this rule. Remember that rules change for this rule, right? So 2 multiplied by 7 is 14 plus 1 is 15, right? You're correct, right? So we can, now you understand a function notation is this thing. When you see y is equal to, or f at x is equal to, or g at x is equal to this is function notation. So you now know three notations: set notation, interval notation, and function notation. So they can represent functions in different ways, right? The first way is the one that I showed you, the mapping diagram, right? Whereby you have the input, the process, and then you have the output. That is one way. Another way is using weights, right? They can tell you that the relationship between two variables is such that one is always, let's say 5 less than the other. So that means that when they say 5 less, it means that it's minus 5. So by so doing, by those weights, they give you the function, right? Because you know that this is the case. For you to get y, every variable has to be 5 less than the other. So sometimes they use weights, sometimes they use tables, like we are going to do all these examples. Sometimes they use tables, they write x and y, and then they give you a rule, of course. Then they tell you that this is -2, maybe this is, let me say this is -3, right? This is -8. Or sometimes they give you this table and they want you to find the rule from this table. Then they tell you when x is 0, y is -5. When x is 5, y is 0. So from this, you have to establish or find what a rule that they used, right? What is the relationship between x and y? What is the relationship between x and y, right? It's as if they give you -3 here and they give you -8 here. So they want you to find the input, the process or the rule. So they can give you this and give you this two. You always have two, you are always looking for one, right? It's either you have the rule and the output, you're looking for the input, or you have the input and the rule, you're looking for the output, or you have the input and the output, but you don't have the rule, right? In this case, our rule will be what? X is -3. So what did they do to get to -8? You minus 5, right? but you have to check if your rule is consistent. 0 minus 5 is negative 5. 5 minus 5 is 0. So it means this is the rule. You get it? Simple. And then they can use set of ordered pairs, like they give you pairs just like I was giving you, to say 2 is to 3 maybe, and then maybe another one, maybe 4 is to 6, and then maybe they give you another one, maybe 8 is to 12. Then they tell you to draw a graph. So what you simply do, you plot these graphs. You plot these coordinates, and then you're done. Or they can give you the algebraic formula. The algebraic formula is the same as the your function notation, right? So they just give you this thing. But obviously, maybe they'll write f of x is equal to this, and then you draw a graph from there. Or they can draw a graph for you, and from that graph, they ask you questions, right? They can draw a graph for you, and they give you those coordinates, and they give you those coordinates, and then they ask you questions. We're going to do this, everything here. In this video, I just wanted you to understand what is domain and range, to understand the different notations they use, because this is the introduction for each and every function that you're going to do. So I will stop here. On the next video, after watching this video, on the next video, what I will do, we will start with the linear functions, and then we'll do everything. We will draw, we'll do its domain and range, and yeah, we'll do everything on it, and then we'll move on to the quadratic and everything. So what I will do, I will send you exercises. Tell me when you're done, so that I can tell if you do understand this. Because if you do, it will make things easier for you when you move along with all the functions that you're supposed to do. So that's it from the from me, guys, for this video. And immediately when you're done watching this video, please tell me. Thank you. Take care of yourself. Remember that God loves you.